Bismillahirrahmanirrahim. Assalamu alaikum to all of you. In this video I am going to design an equivalent circuit model for 5G antenna structure. So this is a 5G antenna and it works at almost 28 gigahertz, and for that I will design an equivalent circuit model in ADS. If you see, this is our page antenna and this is speed line, this is substrate, and this is a port. So I will need to design this antenna, then I will need to design a equivalent circuit for this speed line, and then I will assign a source for providing an AC signal, electric signal to this speed line, and then that speed line will deliver to this equivalent circuit model. So let's begin. First of all, I am designing to an equivalent circuit for this page. So it will looks like a parallel circuit, RLC parallel circuit, which is shown over here. This is a parallel RLC circuit. Capacitance, this is capacitor, this is inductor, and this is this is resistor, and this is inductor, and all of these are connected in parallel with each other with the help of this wire. Now so this is a page which will create electromagnetic radiation, or which will operate at specific frequency band. Now I will need to assign a feed line to this. So for that I will need inductor and capacitor. But before designing a feed line, I want to explain why this capacitor and this inductor has chosen over here. So its answer is, if you see this structure, so here is a conductor which is representing, and this conductor is represented by inductor over here. So this inductor is representing the conduction, this conductive portion of page antenna, while if you see, there is a substrate, and behind substrate there is also a ground plane. So between a ground plane and this page conductor we have insulating material which is like which act like a capacitor. So when there is a capacitor, so definitely there will be a capacitor. So that's why we have used there a capacitor. Now let's come to a resistor. So resistor is 40 ohm. So why is this resistor is 40 ohm? Because the impedance of this port is also 50 ohm, P line resistance is also 50 ohm, input impedance of this port is 50 ohm, while input impedance at this point, I want to say that at this point, that is 40 ohm. Or you can see from your CST file, so that definitely will be between 40 and 50. So that's why I have choose resistance of 40 ohm. Okay, now let's begin to now let's come to design a feed line. So that for that I will need inductor and a capacitor. So I have selected this portion, I have chosen inductor. Now if you see, this inductor is horizontal, so I need it in the rotated form. For that purpose I will enter Control R. So you can see here inductor is rotated. Okay, now I want to choose its value equal to 0.165 nanohenry. 0.165 nanohenry. Now I will need to assign a capacitor. So this capacitor will come over here, but I need this in rotated form, so I will rotate it with the help of, oh no, this is not properly rotating, so I will control Z and I will select I have selected capacitor. Now I will rotate it with the help of control R. Now if I will connect over here, so it will be automatically connect with inductor. Now if you see, this is this portion of circuit is representing patch antenna, and this portion of circuit is representing feed line. You can see this is patch antenna and this is feed line. So its equivalent circuit is, this is patch antenna and this is feed line. Now I will need to assign waveguide for electric source for providing AC signal to this whole circuit. So for therefore I will use this G-tron. Okay, now if you see, its resistance is 50 ohm. Okay, and I have already said to you that input impedance of this patch antenna at this portion is almost in between 50 to 40 ohm, so that's why I have chosen 40 ohm. Okay, now if a signal will start from here, it will pass from this portion and then it will radiate at some frequency, and then the remaining signal will go to ground, and I want to terminate this signal at here, so I will need a resistor of the same impedance equal to 50 ohm. Control R. So with the help of control R, I'm rotating this. Okay. Control Z. Control R. Okay, now I will select a wire, and with the help of this wire I will select this resistor to ground. Okay, now this circuit is almost completed, but I need to change capacitor over here. It is 1 picofarad, and I need to choose a 0.195 picofarad. Okay, so now this circuit is completed, and in next video I will simulate this circuit. So for now, take care and bye bye.